Hello, my name is Caleb Harris, and this is my lab for Physics 2212, Lines of Charge. This lab's purpose was to use charge tape to compare the point charge model to the lines of charge model by dividing the tape into segments and treating each segment as a point charge to approximate change quantity. The main physical principles were Newton's second law of motion, Coulomb's law, and superposition. The main result of the lab was that the gravitational force and electrical force equal 2.17 times 10 to the negative third newtons. The charge on each piece of tape was 2.88 times 10 to the negative eighth coulombs, and using superposition to break the tape into segments is more accurate than treating the entire piece of tape as a point charge. Here are the models and assumptions. For models, you can see the Coulomb's law and the Newton's second law of motion. There's force equal to ma, m being mass and acceleration, and A being acceleration. Assumptions that I made was the air resistance was negligible. Each piece of tape had the same charge, and the charge of each piece of tape is equally distributed along the length of the tape. And models included, that I used through my glow script, was each piece of tape was modeled as several equal segments, and this was necessary so that I could apply the properties of superposition. The system was tape B, and the surroundings was everything else in the universe. For initial conditions, it was just two equal loose pieces of tape, and then a third piece of tape stuck to a table. The experiment consisted of tape B being stuck to the desk and ripped off quickly to charge it. This was caused by leaving behind or gaining more electrons. The tape was hung next to other objects to determine its charge. Then it was placed next to a like charged tape. The two pieces of tape would push each other away, and the distance was measured between them. This distance was used to calculate the charge. Here's some of my data and observations. The length of the tape was 0.221 meters. The mass was 0.000213 kilograms. The distance between pieces of tape was 0.0273 meters. And the gravitational force, which is equal to mass times gravity constant, is equal to negative 0.00217 newtons. And the E force, which is the absolute value of the weight, since it has to be equal, is 0.00217 newtons as well. Like I said earlier, the force must be balanced, and that includes a picture, and also includes a picture of the electric field equation as well. Here's my code. Firstly, I edited the initial conditions so I could put in like the charge, the 1.6 times 10 to the negative 19th, the tape mass, the tape width, the tape length, and the jump distance between the two pieces of tape, as well as the distance. Also then used this next piece of code was used to calculate the electric field and to split the tape into multiple pieces. This was used as opposed to the point charge. This included me splitting up the tape into a certain number of pieces, and n was supposed to be 100. Next, in the top right of the slide, this code simply just creates the model of the tape, and then in the bottom right of the slide, the necessary for loop calculates the electric force on each segment, and then it goes to add up all the electric forces using superposition to calculate the total force. Finally, these lines of the code found the gravitational force and created the appropriate vectors for the gravitational and electric force. This slide is just pictures of my models. The model on the left is the gravitational and electric force when the charge was calculated using the segments. As you can see, the gravitational and electric force are equal and opposite, which is more accurate to the true events within the experiment. On the right, you can see that this was from the previous lab, how it just shows the gravitational force. It lacks the balancing electric force. The main source of error could be that the charge of each piece of tape may not have been totally equal, and that the tape may not have been equally distributed across the tape. Additionally, the charge might have been lost due to my handling of the tape. The main discrepancy is that the finite segment model is more accurate than a point charge model. For the what if question, if I model the tapes as a single point charge like in the previous lab, the gravitational and electric force will not be the same. This suggests that the point charge model was not accurate. As you can see, between my first estimate of the charge and my second estimate of the charge, there's 53.5% difference. For my why question, these estimates differ because we use different methods to calculate the charge. The second estimate, 2.88 times 10 to the negative 8th, is closer to the actual value because the length of the tape was accounted for, and it treats the tape as a segment of charges, not just a point charge. To conclude, the line charge model is much more accurate when it comes to observing charged objects as opposed to the point charge model. When it comes to the line charge model, the more segments an object is divided into, the more accurate the results of the superposition. The difference between the line charge model and point charge model in calculating charge on an object is significant.